Assalamualaikum everyone. Today we are from group 2 would like to present you on Acrylic Acid topic. I hope all of you can understand and enjoy this slide. So I am Ilya binti Muhammad Yusuf. I would like to present on introduction, reaction and mechanism. So Acrylic acid, also known as 2-propanoic acid, prop-2-anoic acid with molecular formula 363H4O2 or CH2 double bond CHCOOH. COOH indicate for carboxylic acid compound. Acrylic acid is also flammable, corrosive, and soluble in water, alcohol, ester, and chloroform. Acrylic acid also have colorless liquid with tart smell. There are various of usage in acrylic acid. As you can see, it can be used as acrylic ester, UV curable resin, water-soluble polymer, and also can be used as polymer flocculant. Next, we move on reaction and mechanism. This figure shows the types of reaction that involve to produce the acrylic acid. First process is catalytic oxidation. This is one of typical process that widely used for production of acrylic acid. Usually, the oxidation of propylene active over mixture of metallic oxide catalyst such as manganese oxide, vanadium pentoxide, and also molybdenum trioxide. Next, for dehydration, there are two pathways for glycerol transformation in acrylic acid. Number one, two-step processes that involve dehydration to acrylamide and followed by oxidation to acrylic acid. Number two, the one-step processing using the vanadium impregnated zeolite beta as catalyst. Next is on carbonylation. Usually in this kind of reaction, this involves the rearrangement of Pl and thermolysis of P3HP provided the efficient ethylene oxide route to the acrylic acid. Fermentation routes is one of biomass-derived sugar provide the opportunities for new potential low-cost route to the chemical intermediate. This involves the combination of fermentation and chemical catalysts provide the multiple routes to produce the acrylic acid. Lastly is rep synthesis. Rep synthesis involves high pressure reaction that catalyzed by the heavy metal, also known as hydrocarboxylation of acetylene with carbon monoxide and water in presence of nickel oxide and copper bromide as combined catalysts.
Assalamualaikum and very good morning to all of my friends. My name is Muhammad Sharil and today I will present to you about the process flow diagram of the acrylic acid. Today I will proceed to the process description of the acrylic acid. And I will present this from the process description, what type of equipment we will be use, the catalyst. Okay, before that I want to say I hope all of you stay healthy, stay safe, stay social distancing, stay one with each other, stay with the family, stay home. Okay, I will proceed to you for the first thing, which is process description. Okay, basically this is the process flow diagram of the acrylic acid, which is the raw material is the propylene. Okay, I zoom in. This is okay. We can see here the propylene. You can see that we have here reactor, distillation column, stripping column, and the product here, which is acrylic acid, acetic acid, and the byproduct will go to wastewater treatment. Click next. Okay, for the process description, we have three process description, which are reaction and quench, product recovery, and lastly the purification. Okay, basically all of these have their own equipment. Okay, firstly for the process equipment, we have 5 process equipment, which are oxidation reactor, quench tower or absorber, stripping column, recovery column, and lastly distillation column or purifier. Okay, basically the oxidation reactor and the quench tower or absorber is on the first process description, which is reaction and quench. Okay, for the product recovery, the equipment are of course the stripping column and recovery column. Okay, lastly the distillation column or purifier will be on the last process, which is purification. Okay, I will proceed. Okay, I will start with the reaction and quench here. Okay, the first step is the chemical grade propylene here. Chemical grade propylene is mixed with steam, and air, and fed to two-step oxidation reaction system here. First step, second step. You can see here first oxidation reactor and the second oxidation reactor, number 1 and number 2 here. Okay, next, in the first step, the propylene is oxidized to acrolein, and in the second step, the acrolein is oxidized to acrylic acid. Okay, both steps are carried out in tubular fixed bed reactor. Okay, the heat generated by the exothermic reaction is used to generate steam. The effluent from the reaction system here, is sent to a quench tower. Number 3 here, you can read. Number 3 is quench tower. The effluent from the reaction system is sent to a quench tower where the acrylic acid form is absorbed in water. Okay, the next step is part of the residual gases obtained by the top of the quench tower is incinerated, with the balance being recycled to the first step reactor here. Alright, the last step for the reaction and quench is the aqueous solution is sent to the downstream units for product recovery here. The aqueous solution, the bottom stream, will send to the product recovery number 4. Okay, for the next step is I will continue to the product recovery. Start from here. Okay, the first step is the aqueous solution from the quench step here, aqueous solution from the quench steps is fed to an extractor, which is here number 4 is liquid extractor, where the acrylic acid is separated by liquid extraction with a solvent. Okay, the next step is the top portion of the extractor here, the top portion of the extractor containing the acrylic acid is sent to a solvent recovery column to recover a two-phase overhead stream here. We will send to the solvent recovery column number 5. Alright, the next step is the two-phase stream is separated and the organic phase, okay, here the organic phase containing the solvent is recycled to the extractor here, recycled to the extractor. Alright, for the next step is the aqueous phase is mixed with the raffinate from the extraction step and sent to a raffinate stripper to minimize the solvent losses here. It was sent here to minimize the solvent losses. Okay, for the next step is the bottom stream from the solvent recovery here. Bottom stream for the solvent recovery column is then fed to the crude acrylic acid column here, where concentrated acrylic acid stream is obtained as the bottom product, whereas the column overhead here, the column overhead stream mainly comprised of acetic acid here, and light impurities is sent to a recovery column here. Number 8. Okay. The next step is the bottom stream from the recovery column here. Number 8 is recovery column. You can see here the bottom stream from the recovery column is sent to the crude acrylic acid column. Number 7 here, sent to the crude acrylic acid column, and the overhead stream is recycled back to the solvent recovery column number 5 here. Alright. Okay, next I will proceed to the purification, which is the last step, the last process description, as I mentioned before. For the purification, the first step is in the purification area, the concentrated acrylic acid stream from the crude acrylic acid column, number 7 here, the concentrated acrylic acid stream from the crude acrylic acid column is fed to the product column. Product column is number 9 here. Yes. Then in this column, ester grade acrylic acid is obtained as the overhead product here. Okay. The next step is the column bottoms are sent to the dedimerizer here. Then number 10, dedimerizer, to convert the dimer impurity formed in the process back to acrylic acid. Okay. Finally, the product from the dedimerizer here, dedimerizer number 10, the product from the dedimerizer is sent to the bottom stripper column, where the heavy ends are separated and sent to waste. Okay, this is Same as I explained to you just now. If you don't understand what I said, you can read it here, here, and here. Alright. The catalyst used in the production of acrylic acid is manganese oxide Mn2O3, vanadium pentoxide V2O5, and lastly the molybdenum trioxide MoO3. Okay, that's all. My friends, we'll continue to proceed with the next presentation. That's all from me. Thank you.
I am Fatiha, and here is the acrylic acid safety measures. In this part, the proper safety measures of handling acrylic acid will be discussed, and we will get to see some of the danger on handling acrylic acid. Is acrylic acid harmful or hazardous? The answer is yes. Acrylic acid is hazardous, flammable liquid organic substance, and it is also highly reactive that it will readily polymerize if it is not properly controlled or stored. Alright, let's move on to the potential health effects by the acrylic acid. So firstly, it is harmful if swallowed, and swallowing results in severe gastrointestinal irritation. While if it can contact with the skin, it will result in skin irritation or burns. The vapor concentration of acrylic acid is attainable at room temperature. However, exposure of an hour or more can lead to injury or death. Acrylic acid can cause a severe skin irritation, swelling, and chemical burns, as it has the capability of disrupting the tissues of the skin too. So the liquid acid can cause blindness in the eyes, and also the vapor or mist of acrylic acid can severely irritating the respiratory tract. Exposure of acrylic acid might happen during these processes, which involves cleaning, maintenance, transfer, or might be sampling and analysis. So among the important measures of safety and health control during the handling of acrylic acid or the production of acrylic acid, firstly is providing appropriate local exhaust ventilation. Secondly is to provide the eye and hand wash station as well as safety showers that are close to the workstation. And lastly, the PPE, which involves safety goggles, respirator if ventilation is insufficient, gloves, and also the full protective suits. So you can exactly see the figure there. There is a man with the full protective suits. So that is the example of the full PPE. Thank you.
Okay, now let's move to pollution control. Polymerization inhibitor is added to commercial acrylic acid to prevent the strong exothermic polymerization. This is because acrylic acid polymerizes easily when exposed to heat, light, or metal. Uncontrolled polymerization is rapid and can very violent and may cause explosion. From that explosion, we might accidentally release unwanted pollutant to the environment. Since production of acrylic acid will produce formaldehyde, we need to treat formaldehyde by using Ventern process in IETS. Ventern process is one of the example of chemical oxidation process. Acrylic acid can be disposed by incineration that can be handled by firms that are capable of handling solid waste materials. Gas waste produced will be treated by installing air pollution control systems such as flash stack. Air pollution control system used to remove pollutants from gases discharged are also required to meet federal, state, and local standards, including regulations on the disposal of waste from the control devices, such as scrubber water and incinerator. So, non-compliance is subjected to significant civil and criminal penalties.
Now, we move to the next section, which is waste management. From production of acrylic acid, three types of waste were generated, which are scheduled waste, gaseous waste, and wastewater. All these three types of waste have to be managed and disposed correctly to avoid pollution. For solid waste, it's come from the used catalyst from the reactor, personal protection equipment, sludge from the wastewater treatment, and contaminated matter. It usually will be sent to the scheduled waste facilities to be treated or disposed. For wastewater, production of acrylic acids produce wastewater containing formaldehyde, which is a toxic substance. The wastewater also have high reading of BOD. The wastewater need to be treated in the Industrial Effluent Treatment System (IETS) before it can be discharged. The gaseous waste produced from the acrylic acid production have high content of VOC and carbon monoxide. Flash tanks are the most common air pollution control system used to treat the gaseous waste before it can be released to the atmosphere. Next is environmental issues and acts. Environmental issues not only comes from the production of acrylic acids, it also comes from its derivatives or products such as acrylic resins, plastics, and paint. First issues is acrylic products such as acrylic plastics are flammable, and it must be protected from the combustion source. Burnt acrylic plastics release hazardous substance to the environment. Second is, acrylics are hard to recycle and not biodegradable. It requires special handlings and equipment. It is considered as a Group 7 plastic and mostly not collected for recycling. Many recycling companies do not have the facilities or expertise to recycle acrylics. Due to this, acrylic is one of the least recycled types of plastic, which means it is having a devastating impact to our environment. Third is air pollution. As stated in waste management section, the gaseous waste produced from the acrylic acid plant have the high content of VOC and carbon monoxide. If the APCS is not installed or operated appropriately, the high amount of VOC and carbon monoxide will be released to the atmosphere. The fourth issue is water pollution. Also have been stated in waste management section, production of acrylic acid produce wastewater containing formaldehyde. The wastewater also contain high amount of BOD. If not treated, the discharged wastewater may lead to the water pollution. The fifth issue is hazardous and toxics. High toxic substances were used in production of acrylics, and incineration of acrylics product release hazardous compound. The manufacturing process of acrylics use highly toxic substances such as cadmium and lead as chemical additive. Incineration of acrylic waste produce polycyclic aromatic hydrocarbons. Long-term health effects of exposure to this compound may include cataracts, kidneys, and liver damage. As a countermeasure of all those issues, few steps have to be taken and implemented. Firstly, reduce the use of non-biodegradable material. By reducing the use of plastics and other non-biodegradable materials, the production of acrylics product will be decreased. This can reduce pollution and hazardous fume emission. Second, build Industrial Effluent Treatment System (IETS). IETS is required to treat the formaldehyde content in wastewater from acrylic acid plants before the water can be discharged. Next is chemical additive. Apply chemical finish to the acrylics products to increase the resistance to UV and fire to make it less flammable. Use less toxic chemical as additive in acrylics production. Lastly, install Air Pollution Control System (APCS). By installing the APCS, the volume of VOC and carbon monoxide emission from the acrylic acid production can be reduced.
Bismillahirrahmanirrahim. My name is Muhammad Shukri bin Al-Rahim. Now I would like to present about the sustainability of the acrylic acid and the conclusion for today. Sustainability of acrylic acid. Nowadays, effort to reduce atmospheric carbon dioxide emission and the increasing concern about the availability of fossil raw material has led the chemical industry to search for alternative bio-based feedstock for acrylic acid production. For example, lactic acid can be produced biotechnically via fermentation of the carbohydrate and further can be critically dehydrated to acrylic acid. Lactic acid produced by the fermentation combines low production costs and minimization of oil consumption. Therefore, it represent an attractive and environmentally friendly alternative as a feedstock for the production of the bioacrylic acid. Now, as the conclusion, acrylic acid with properties of colorless in color, of liquid with a touch smell, flammable and miscible with water, alcohol, and ester. Besides, there are many types of reaction to produce it, such as catalytic oxidation of propylene, propane, dehydration, and etc. Production of acrylic acid produce solid waste, gaseous waste, wastewater. Solid waste will be sent to the scheduled waste facilities. Gaseous waste will be treated using flare stack, and water will be treated at ETS. Acrylic acid has three process descriptions, which are reaction and quench, product recovery, and purification. The highlight process is oxidation process. Catalysts used in the acrylic acid production are manganese oxide, vanadium pentoxide, and molybdenum trioxide. Environmental issues come from the production process of acrylic acid and its products such as acrylic acid, plastic, and resin. And to countermeasure it, we must reduce the uses of plastic, replace the toxic chemical that being used in production of acrylic acid, then apply the chemical additive to make the less flammable, and lastly install ETS and the APCS for the air and water pollution control.